Welcome to This Explainer. We're jumping right into one of the most bizarre geological anomalies in North America today. It's a place affectionately and officially known as the Driftless Area. Along the way, we're going to unpack some wild academic drama too. So let's get into it and figure out what makes this region so absolutely incredible. Here is the big mystery we're unraveling. Picture this. Massive, continent-crushing sheets of ice are moving south, literally flattening everything in their path. Yet somehow, this one huge patch of land just dodged it. It completely escaped the last ice age. We're definitely going to explore the geology of how that physically happened, but we're also digging into a historical whodunit. Because as it turns out, the history books gave credit for this discovery to the completely wrong person for a very long time. You know how the American Midwest is generally famous for being incredibly flat? That's because the landscape was scoured and leveled by those ancient glaciers, acting like giant bulldozers. But in the driftless area, the ancient flat-lying bedrock was never crushed. Instead, it was left alone for thousands of additional years to erode naturally. This created these towering sandstone pinnacles, incredibly deep river valleys, and karst topography full of sinkholes and caves. It's a stark, wild contrast to the flat, glaciated landscapes surrounding it on literally every side. Just to wrap our heads around the scale here, we are not talking about some hidden little valley. This untouched area spans roughly 62,200 square kilometers. It stretches across 4 contiguous states: southeastern Minnesota, northeastern Iowa, northwestern Illinois, and the vast majority of it sits right in the heart of southwestern Wisconsin. Because it acted as this ice-free safe haven right in the middle of a continental ice sheet, it actually harbors unique biological relics to this very day.
Now, before we get too deep into the weeds, we got to define our terms. What exactly does driftless mean? Well, to understand that, you need to know what drift is. Drift is just a term for glacial deposits. As glaciers move, they churn up tons of sand, gravel, and till. When the ice eventually melts, it leaves all that debris behind. So, the driftless area is exactly what it sounds like, a massive region that is entirely devoid of these specific glacial deposits.
The history behind how we understood this drift is actually pretty wild. Back in the 19th century, before modern geology really took off, scientists were totally baffled by these random deposits of gravel and massive boulders. Some folks backed the iceberg theory. This was the idea that the interior of North America was once covered by a giant inland sea, and drifting polar icebergs would melt and drop boulders onto the land. That's actually where the word drift originally comes from. Eventually, the glacier theory won out, proving that it was continental ice sheets moving the Earth, not floating icebergs. But you know how it is, the old terminology stuck, and that's why we still call it the driftless area today. Section 1. Defrocking the False Father. Okay, here's where the historical drama kicks in. For decades, tourist literature and even actual textbooks credited one specific man with discovering that this area was unglaciated. But as we start looking at the evidence, you'll see this lone genius narrative is completely false. We've got a record to correct. Enter William H. Keating. He was part of an 1823 expedition through the region. Now, the funny thing is, Keating himself never actually claimed he discovered the driftless area. That whole story was manufactured much later by a University of Wisconsin geographer named Lawrence Martin. In 1915 and again in 1923, Martin published articles aggressively claiming Keating was the sole discoverer. Martin's articles were so influential that this error just kind of crept into modern books, with some people even falsely claiming Keating coined the very word driftless. So, what was Martin's smoking gun for this massive claim? It all hinged on something called the painted stone. During Keating's 1823 travels, his party stopped to look at a huge 4.5-foot erratic boulder. It was highly venerated by local Native Americans who had painted it with red pigment. Keating jotted down in his journal that it was the first boulder of primitive rock they'd seen west of the Rock River, pointing out how out of place it looked compared to the local sandstone. Lawrence Martin took this one single journal entry and retroactively used it as proof that Keating somehow understood the entire region was unglaciated. But honestly, the whole myth falls apart when you just read Keating's own writing. In 1825, Keating actively admits he has no clue how that boulder got there. He wrote that he couldn't accept theories about subterranean explosions or icebergs, and he concluded, quote, "The rest must be a matter of speculation, and we are not disposed to indulge in it." Plus, Louis Agassiz didn't even popularize the glacial theory until 1840. That's 17 years after Keating's expedition. Claiming Keating knew he was in an unglaciated driftless area is totally anachronistic. He didn't use the words drift, driftless, or even erratic in his narrative. And here's the absolute kicker. Keating not only lacked the geological framework to understand what he was looking at, but he completely missed the defining feature of the driftless area. Think about it. Much of the United States is technically driftless, simply because the glaciers never reached the deep south. What makes this specific spot in the Midwest unique is that it is bounded on the south by glacial deposits. It's a literal island surrounded by glacier evidence on all sides. Keating completely missed this southern boundary, which is the exact thing that makes the enclave a geological marvel in the first place. Section 2. Mapping the driftless area. So if we cross Keating off the list, who actually gets the credit? Well, it wasn't some sudden eureka moment by one guy wandering through the woods. It was a decades-long grind of careful cartography and observation. In 1862, a geologist named Josiah D. Whitney published a diagram of the region destitute of drift. He mapped out parts of it, but left gaps at the top and bottom. Then, in 1874, John S. Newberry finally put together a map with a closed boundary specifically labeled the Driftless Area. Finally, Thomas C. Chamberlin came along in 1878 and 1885, publishing incredibly detailed boundary maps. By 1885, we got these incredibly detailed maps from Chamberlin and Salisbury. They showed a distinct, lighter-colored region right in the center, the Driftless Area, beautifully and clearly bounded by the intricate glacial patterns surrounding it. The level of detail was immense, which just proves how far the science had actually evolved. It kind of makes you realize why historian Lawrence Martin might have lazily picked Keating as the discoverer. When you have a complex web of scientists like Whitney, Newberry, and Chamberlin all contributing piece by piece over decades, it's way harder to tell a neat, simple story than just pointing to one explorer from 1823. Section 3. The Three True Fathers. But we prefer accuracy over oversimplified myths, right? So let's talk about the true fathers of the driftless area concept. And yes, fathers, plural. Because in science, breakthroughs rarely happen in a vacuum. The historical record shows that the correct modern understanding of the driftless area was arrived at through a simultaneous discovery in 1877. 3 different geologists, Roland D. Irving, Newton H. Winchell, and Thomas C. Chamberlin, all independently and simultaneously explained the phenomenon. They recognized the role of continental glaciers, they mapped the boundaries, and they figured out the mechanics of how this massive patch survived untouched. It's a brilliant example of how scientific discovery is usually a collaborative, parallel realization. Section 4. How it remained driftless. So, what was the grand conclusion these 3 scientists arrived at? How did this giant pocket of land dodge millions of tons of crushing ice? The 3 geologists independently adopted what we call the divided and diverted theory. Imagine the advancing continental ice sheet as a massive, slow-moving river of ice. As it pushed south, it hit these really strong elevated highlands. Ice is going to follow the path of least resistance, right? So the glaciers were divided by the highlands and channeled away into deeper, weaker river valleys nearby. Essentially, the icy fingers of the glacier closed completely around this ancient region, but they failed to close upon it. The ice just bypassed the tough terrain, leaving it perfectly preserved as an island in a sea of glaciation. And amazingly, this divided and diverted explanation is still the widely accepted theory today. Which brings us to the end of our explainer today. We've solved the geological mystery of how the ice bypassed this stunning landscape, and we've solved the historical mystery by giving credit back to Irving, Winchell, and Chamberlin while retiring the myth of William H. Keating. But I want to leave you with a larger thought to chew on. If the popular history of the driftless area could be warped for an entire century just to prop up a single false father, instead of acknowledging a messy, collaborative discovery, what other lone genius discoveries in our history books are actually just well-marketed myths? Keep questioning the narrative, keep looking at the evidence, and I will see you in the next explainer.